Okay, so uh, the first question we'll look at, we've been given that the set A negative 3 comma 2, and then the set B is from 0 to 7, and then the set C is from negative 5 to positive 1. And then we've been given also the universal set U, which is from negative 10 up to positive 10. So the questions are, want to find A intersection B complement, and also we want to find A minus B minus C complement. Okay, so how do we find these sets? So find and show them on a number line. So if they've said find and show on a number line, so you just have to show a number line. But if they're just find the following set, then there's no need of showing on a number line. So in this case, we're just going to find and also show on a number line. So let's get started with A. The first thing I'm going to do is I'm going to put first the set B. We can see B starting from 0 up to 7. And look at the type of brackets used. Those are called closed interval brackets, meaning we're including 0, we are also including 7 in B. Now we are interested in B complement, that is what is outside B. So I'm going to put a circle here, I'm also going to put a circle here. Since 0 is in B, then it can't be outside B. That's why you've seen I've not shaded those blue circles. And then we'll start going in this direction, what is outside B, and also in this direction. We shouldn't exceed the universal set because every element we're talking about should be part of the universal set. The universal set, this side ends up to 10, this side ends up to negative 10. As you can see, negative 10 and 10 both are not included in the universal set because it's open. So also here to be open, even here to be open. So this is B complement. And then now we're going to get the set A, or put on this set or in this number line. The set A is from negative 3 up to 2. We are not including negative 3, but we are including 2. So now we want where A is intersecting with B complement. Where are they meeting? So you can see that A and B complement are meeting here. That's the only region they are meeting. So therefore for this question, A intersection B complement is going to be from from negative 3 up to 0. Please always write a smaller number first before a bigger number. If you don't, you'll be wrong. Now you need to know the brackets that you are using also. If you see, we are talking about the intersection, but 0, negative 3 is not in the set A, it's open there. So negative 3 cannot be part of the intersection because it's not in set A. Intersection means what is appearing in both. 0 also is not in B complement, so it can't be part of the intersection, so also here to be open. You can write the correct thing, but if you use wrong brackets, then the answer is wrong. So that's the answer for that one. Is there questions? Any question? All right. Yes, go on. The number line? Okay, so a number line is a way of representation of sets which are given in interval form. If you look at the sets, all these are giving you like the numbers through which the set is lying. So for example, set A starting from -3 up to 2. So that's why we use a number line to put those sets. Actually, all set operations here, we don't use Venn diagrams, but we'll be using number lines. So we need to familiarize ourselves with how to use number lines and how to put sets on a number line according to the way they've been given. Okay. So the first thing is you put the set B on the number line, and you can see B starting from 0 to 7, and we're including both 0 and 7. And then at 7 I'm going to now put a dot, start going in the region that is outside B, but it should be part of the universal set, so the universal set ends at 10. And then also at 0 I'm going to put a dot, start going in the region outside B. Then I'm also going to end at -10 because that's where the universal set starts. After then, and then I'm going to get that says B complement, this and this, that's B complement. And then I'm going to get the set A, starting from -3 up to +2, as you can see here. But we are not including -3 because of the type of bracket used. That's open, and then we are including 2. So that's why I've shaded here. Now I want where B complement, the lines in blue are intersecting or meeting with the line in white. So that's the region that I've shown. Okay. Now we can do B. So before we answer this one, we need to simplify it. So I can now express this minus, I'm going to express it as an intersection. So we're going to have A intersection B minus C. We have got a complement there. There will be another complement. Every time you change a minus into intersection, then on the second part you are going to have a complement, but you already have one complement, so there will be now two. And you know that two complements cancel themselves, so that will just be A intersection B minus C. Does that make sense? You do what? Yes. Then you would have changed. Then you have changed the question. Yeah. And then from here we also say A intersection. Again, what is inside, you also have a minus, so we are going to change. This is B intersection C complement, like that. Now we can answer the question. Yes. Yes. So in this case, it's the second part. You see, the minus was subtracting this part. So the one which carries the complement is the whole of this part. Yes. Yeah. Just like you can see, it was B minus C, but the second part, which is a C, that carries the complement. Okay. So again, let's first put the C because it's the one with the complement on the number line. And we can see C starts from -5 up to 1. and we are including negative 5. We are not including 1. Why? Because it is open at 1. So this is the set C. But this, remember, this we are talking about is C complement. So I'm going to put a dot here, but I'm going to shade it. Why? Since C we have not shaded it. Then I'm also going to put a dot here. I'll not shade it because in C I've shaded. We'll start going in this direction, but we can't exceed the inverse set. The inverse set ends at 10. And then we also go in this direction. Inverse set ends at negative 10. So this is C complement. I can even remove C because it's not of our interest. We are just interested in C complement. And then I'm going to get B. B is starting from 0 up to 7, as we can see. So 0 will be somewhere here. 7 might be somewhere there. And we're including both 0 and 7. So it will be like that. And then here, this is B. Now we're talking about B intersection C complement. So where are these two sets intersecting? So we can see that it's here. That's where they're intersecting. And then I can remove, so I'm going to put, you can see that 1 is shaded there and 1 is present there. So 1 is going to be part of what? The intersection. And then here also 7 is there, and also 7 is within this line. So it is also going to be part of the intersection. So that is going to be B intersection C complement. And then I can now remove this. And then now we'll look at A, the set A. The set A is from negative 3 up to what? Up to 2. So let me set 2 is here. And we are not including negative 3, but we are including 2 there. So now where is A intersecting or meeting with B intersection C complement? We can see it's just here. Therefore, the question we are given, A minus B minus C complement, is just going to be from 1 up to 2. We can see 1 is part of the intersection, and also 2 is here. 2 is also part of this line. So that is going to be the answer. So that is it.